Erroneous agricultural practices have played a major role in speeding up climate change and its devastating impacts on our planet, leading to a global decline in food security. International institutions have been striving for years to rectify these practices, recently converging on the concept of regenerative agriculture. This approach embraces cutting-edge, proven methodologies that not only mitigate the impacts of climate change, but also maintain crop productivity and enhance the viability of agricultural investments. Green Mawared Company has designed the Khabab Regenerative Farm for olive cultivation to become a comprehensive economic agricultural entity. Endorsing regenerative methods. It aims to bolster food security in Syria and across the world, and to create an Arab regional hub for the production and development of specialized skills in this critical field. The agricultural complex is located between the villages of Khabab and Al Majedel, near the Daraa International Highway. Its area exceeds 250 hectares. With a 7 kilometers perimeter. Let's first acquaint ourselves with this innovative project through a numerical summary. 100 specialized skills. The number of engineers and administrators operating the agriculture complex. 200 labor skills. The annual count of seasonal workers involved in the agriculture complex. 350 specialized skills. The amount of effort required to launch the project. 135 billion Syrian pounds. The cost to establish the project. 36 months. The time frame for establishing the project. 8 years. The expected duration to achieve a full return on investment. 1 megawatt. The capacity of renewable energy systems, wind and solar, powering the complex. 35 types. The number of plant and crop species used in the agriculture complex. 100,000 trees. The count of olive trees planted. 10,000 square meters. The area of administrative, industrial, research, and training buildings. 250 hectares, the initial area of the complex. 20 wells. The number of wells to be prepared to meet the agriculture complex's needs. And now, let's take a closer look at the agricultural complex to better understand its components and the methods used in applying the principles and practices of regenerative agriculture. The agricultural complex is surrounded by a belt providing protection from external factors, such as intruders, stray animals, and harmful winds. This build comprises a stone wall built using the black stones found around the farm, prickly plants like cactus, Damascus rose, and brambles, as well as high windbreaks such as cypress, walnut, quinoa, poplar, pine, and medium-sized such as acacia and lupina. All of these plants are used to generate additional income for the farm, and some serve as feed for the animal wealth. Olive trees form the main component of the agricultural complex, housing around 100,000 trees. These are evenly divided into varieties for olive oil production and varieties for table olive products. The spaces between olive trees are utilized for planting legumes and fodder crops, which prevent soil erosion, assist in fertilizing the olive trees, secure additional income for the farm, and provide the necessary fodder for animal wealth. Green Mawared Company designed the irrigation system of the agricultural complex, using surface tanks in the form of lakes located at each well used for irrigating the crops. These lakes are used for fish farming, water storage for plant irrigation, as their waters contain fish waste rich in organic fertilizer. They also serve as a rich environment for the growth of water-loving plants like willow and alder. These lakes help moderate temperature under harsh weather conditions, whether intense cold or extreme heat, and enhance biodiversity, thus strengthening the farm's ecological system. The agricultural complex contains its own nurseries, benefiting from the remnants of trimming trees and planted vegetation to produce high-quality seedlings for additional income. The nurseries consist of open spaces, plastic houses, and special sections within a controlled environment agriculture building, managed by advanced digital systems. Around the administrative buildings area, there are small orchards known as food forests, aiming to increase biodiversity within the farm as a whole, and cultivate crops to provide the facility's owners and employees with organic food products. These food forests consist of areas for planting seasonal vegetables and areas for planting fruit trees, nut trees, and apple trees. Here we arrive at the building area of the facility, which we chose to build using the black basaltic stone prevalent in the project land. We start first with the main administration building. This building includes management offices, an IT center, and a global agricultural training academy that welcomes students and specialists to train them on the principles of organic and regenerative farming, digital agriculture techniques, foundations of agricultural economics, and scientific agricultural research methods. Theoretical instructions are supported with practical applications available within the farm. The Academy also offers accommodation services for trainees as part of training camp programs. Following this building is the Agricultural Research and Laboratory Building, dedicated to carrying out organic and regenerative farming research and testing digital agriculture techniques. This building offers research services to develop crops and organic care methods, as well as strategies to increase agricultural investment profits. It also conducts necessary analysis procedures to monitor plants and trees to ensure accurate irrigation and feeding, and the quality of products. The Agricultural Academy and the Research Center form one of the most crucial pillars for promoting regenerative farming sciences and establishing important relationships with research centers and international and academic institutions worldwide. The third building is the Protected Agriculture Building, which uses the latest digital farming technologies to provide a controlled environment with accurate temperature, humidity, lighting, and irrigation. Within this building, grains are germinated for use as animal feed. Some plants that require special conditions to germinate are cultivated, and agricultural research is conducted. This building also includes a special section for students to carry out research related to training courses. Following these buildings is the area for factories and food warehouses, which include olive presses, olive table product packaging and wrapping plants. These factories play a significant role in achieving self-sufficiency for the farm, reducing reliance on external services, and ensuring the quality of food products. In the future, it might be worth considering the addition of other specialized food factories for the plants grown within the farm, producing cosmetics and medicinal oils. Following the food factories are the agricultural factories and warehouses, which include a natural fertilizer and organic nutrient solution plant and special feed factories for animal and fish wealth. At the end of these buildings are the animal wealth breeding and housing buildings for sheep and poultry, each separately. The facility also includes a special area for beekeeping with the aim of contributing to increased biodiversity, enhancing crop production, and obtaining additional income from various bee products. Green Mawared Company has leveraged its expertise in digital agriculture to ensure the successful establishment and efficient operation of the agricultural complex by making modern agricultural technology a foundation. These technological means include drones for monitoring work progress, early warning against fires, and for detecting diseases that may affect the crops. Precision agriculture technology is used to manage irrigation and fertilization optimally through the use of wireless digital sensors for soil moisture and nitrogen quantity. These sensors transmit the measured values to special receivers spread across the farm to accurately determine appropriate irrigation amounts and fertilizers. These receivers are connected to a central monitoring system that allows agricultural engineers to monitor soil moisture and nitrogen content for all plants. Information systems for enterprise resource planning (ERP) have been adopted to manage the financial, human, and agricultural resources and operations of the farm, as well as to keep maintenance, evaluation, and monitoring records. Technologies of the controlled climate environment are used to operate the grain germination rooms to obtain green fodder for animal wealth throughout the year, to propagate some plants that need specific weather factors of temperature, humidity, and light, and to conduct agricultural research that requires a closed environment. To monitor animal wealth, Internet of Things, IoT, technologies are used to track the breed of animals, their health status, behavior, and feeding through equipping each animal with a digital identification card using RFID technologies. Finally, food chain monitoring systems are used to document the organic nature in all farm products, to meet the conditions of cooperation and joining international organizations concerned with organic food and medical products, and to market the products to interested markets. These systems also help in meeting the conditions of international organizations to obtain carbon offset vouchers, which are certificates issued by international organizations to facilities that absorb carbon to encourage them to adopt environmentally friendly practices. Green Mawared Company has adopted a fundamental principle in designing its projects, which is the adoption of renewable energy solutions from sun and wind in operating and managing the agriculture complex. In the end, we hope that we have entertained you with this tour, in which we reviewed the design accomplished by Green Mawared Company for the Khabab Regenerative Farm for Olive Cultivation. Thank you for watching, and may God keep you safe.